So just recently I have confirmed correct database setup with my well planner, and I'm going to drill the well on the slot number 2. The well name is U5103. So I have this actual well bore and plan well bore here. So on the plan well bore I have this active revision, which, as I've said, I've already confirmed with a well planner and with a customer representative, so the database setup is okay. I'm going to drill this particular hole section with a motor assembly. So this is the depth range of my BHA, and let's take a closer look to directional objectives of this run. So as you can see from our well plan, directional objectives are to kick off from vertical with dogleg severity 0.6 over 10 meters, and then to build to 18 degrees in the azimuth of 36.8 with dogleg severity of 0.8. After that, we'll keep on drilling a tangent all the way to section TD. Let's check if active monitoring is required. We go Outputs and run a clearance report with risk assessment rule applied. So now I scroll down to summary, and in summary here I see that active collision monitoring is not required. Now let's take a closer look to our BHA. So this is my BHA, and I'm going to use 9.5 inch Ultra XL VS motor with AKO 1.2 in a 12 inch hole section. So now let's estimate how much slide will be required and what is expected motor yield. If there is no local experience with this particular BHA setup in this particular formation, so build-up rate chart will be required. To access build-up rate chart book, managing the job cycle application can be used. Here, in a managing the job cycle application under design and plan, I have build-up rate charts. So now what I have to do is to find build-up rate chart book which corresponds to my motor configuration. And I know that I'm using 9.5 Ultra motor. So that's exactly board chart book of my interest. On the left part of this document, opened in PDF format, you can see that there is a table of content, and I would like to find my my particular configuration and just to click on that. So I'm looking for 9.5 Ultra XL in 12 inch hole, and I know that I don't have any stabilizers in the BHA, so slick configuration is exactly what I'm looking for. So I click on this one. When build-up rate chart is open, so first you double check your selection, and then you can go to build-up rate chart itself. From this build-up rate chart, you can estimate how much build-up rate you'll get from the AKO setting and what will be the maximum string RPM. So in this case, I know I'm going to work with 1.2 AKO angle. That results in roughly 4.8 degrees over 100 feet of dogleg severity or build-up rate, and at the same time my maximum string RPM will be approximately 78 RPM. If BHA configuration cannot be found in build-up rate chart book, then Geoboard engineering application can be used instead. So in this engineering utilities application, we are working only on Geoboard tab. And first we would like to use this motor wizard, which allows us to select a motor from the catalog. So we have to specify bit lengths. In our case it was 0.4 meters. Bit diameter, which is 12 inch. Sometimes you work with bit diameters that are not presented in this drop-down menu. In this case, you just select the closest and you will edit it earlier on the main tab of Geoboard. Motor size, I know that this is 9.5, and motor type is Ultra XL VS. We have Ultra XL and Ultra XL VS here, but geometrically speaking, from the outer body geometry, they all the same. So there shouldn't be any difference if I select either of them. So I'll select Ultra XL VS. For stabilization option, it will be slick. If you have any other stabilization, you just select partial or full and you specify stabilizer diameters accordingly. I press apply. Okay, so now all these cells, they are filled from the catalog. So what I have to change is my alpha 3, which corresponds to my AKO setting. My alpha 3 will be 1.2. So now everything is set up. I apply one more time and I run the calculation. Now I want to run the report for Geoboard calculation. So when you scroll down, you have these 4 options. So each option or position describes the expected geometrical outcome of the motor configuration in each scenario. First position is build in inclined hole. Second is kicking off from vertical. Third is maximum possible build-up rate. And fourth is when you are going to drop in inclined hole. So all these numbers here from 3.6, 1.26, 9.32, 11.62 give you a reasonable range of what to expect from this motor when you are doing either of these operations. As you can see, my previous number from build-up rate chart book, which was roughly 4.8, is somewhere in the range. Now Didi has to use his judgment and previous experience. Let's say if we are kicking from vertical with dogleg severity of 1.8 per 100 feet, so that may require longer sliding distances. But once we have kicked off already, so we will reduce our sliding percentage accordingly. Required slide percentage can be calculated by dividing required build-up rate over motor yield. Like in this case, if we are going to kick off with 1.8 per 100 feet, so my sliding percentage is going to be over 100. That means that I may have to perform full stand sliding. But again, once I build some sort of inclination, the percentage of sliding will decrease. And of course, these values will be adjusted once actual service will be obtained and actual motor yield calculated. So now we can start drilling. I I opened my actual well pass and I'm gradually approaching this kickoff point. So that's my current bottom of the hole, and my clearance tab was set up for passive monitoring, and that means that my alternate rule is Baker-Hughes assessment required. My look ahead is 100, and right now you can see this warrant status. This is only because this available space, but my look ahead looks not bad, so it's safe to resume. And on distance from plan tab you can see that I'm a little bit ahead of plan, and I have this azimuth difference which will bring me more and more to the left of my trajectory. So I'm approaching this kickoff point, and that's exactly what I'm going to so now I'm approaching my kickoff point, and I'm going to в пизду, короче. To track my sliding performance, I have created this slide sheet. So this is a good visualization for your sliding performance, for your motor yield calculation, for projection purposes as well. It doesn't mean that it should be necessarily done in Excel format. I did it just for demonstrational purposes. You can do it even manually. So what it shows that I'm drilling with a stand, and inside the stand I have this joint breakdown. So I'm drilling with 28-meter stand consisting of 3 approximately 9-meter joints, and so when I drill stand down, this will be my bottom of the hole depth. And this triangle here shows the position of directional sensor when I take a survey. So the distance between this triangle and the end of a stand represents the sensor to bit offset plus stick up when I take a survey. So when I take a survey and I put the numbers here, I'm pretty sure about the inclination and azimuth at this point, but I can use the trend and I can use the slide unseen in order to project to the bottom of the hole, and in order to project my and in order to plan my next slide. So now we drilled another stand in rotary mode. So I just use this curve to show that I'm using rotation of the drill string, and I took a survey at this point where my stand was drilled, and it's showing inclination of 0.7 and azimuth of 3.3. So from 520 meters of measure depth, I'm about to kick off. When I pause this survey in Vol Architect, I also use projection to bit option as a tangent, and I use this bit offset, which exactly equal to distance from my sensor position to the stand down position. And from distance from plan tab, I can see that I'm still a little bit ahead, so I'm increasing this distance ahead, and I'm going more to the left, again because of my azimuth difference. My clearance tab is still showing this small available space, but that's not a treat. So now another stand was drilled, and that's how we decided to drill the stand. So first we have to create some room in order to enable our two-phase orientation, and we've drilled 8 meters in rotary mode. Then we stopped rotation and started to orient the two-phase. As far as our inclination is below 3 degrees, so that means that we are going to use magnetic two-phase corrected, and we performed 7 meters of slide in the azimuth of 30 degrees. Then after that we started rotation again and drilled in rotary mode remainder of the stand. So afterwards we took a survey that showed that our inclination is 1.4 and azimuth was 358. So I'm building inclination and turning to the right. When I post this survey in Architect, I can see that my dogleg severity achieved was 0.37. And all this dogleg was between these two survey points. So from this survey to this survey. So 1, 2, 3, 4, 5 meters of slide gave us 0.37. We still have 2 meters of slide unseen, and that's exactly what we're going to use while projecting on the bottom of the hole. Now actual motor yield can be calculated by using this simple proportion. So motor yield is equal to actual dogleg severity multiplied by course length, which equal to stand length if you are taking survey each stand, over slide distance seen between two survey points. So in my case, when I put all these numbers here, my motor yield was 2.1 over 10 meters. So now, in order to create projection to bit, I'm going to use dogleg severity, which comes from slide distance unseen over course length multiplied by motor yield. So I still have 2 meters of slide unseen. My course length will be the remainder of the stand, which corresponds to my bit sensor offset, and my motor yield will be exactly this number. So now, in order to project to the bit, I'm going to use dogleg severity 0.3. And in Wheel Architect, I'm going to use inclination and azimuth option because they don't have any magnetic two-phase corrected option in Wheel Architect. So I have to tweak these numbers in order to get 0.3 dogleg severity. So let's say I did it already, and 1.41 inclination with 15 degrees of azimuth gives me roughly 0.26. Now that's what I used for projection to bit option here, my projected inclination and azimuth at the bottom of the hole, and this is my expected dogleg severity. So again, I check the clearance tab, it's safe to proceed, and I check the distance from plan. So at the bit, again I'm going a little bit ahead, but now my inclination difference is negative, so it's not a big problem. But now I'm going to be even more left because I still have a negative azimuth difference. So now let's drill another stand. Another stand was drilled, and now we have 4 meters of rotary just to have some space for two-phase orientation. Then we performed 9 meters of slide in 40 degrees of azimuth, and then we rotated the remainder of the stand. So when we drilled the stand down, we took a survey which showed an inclination of 2.84 and azimuth of 19.11. When I pause this survey in the Architect, I can see that dogleg severity achieved at this survey point was 0.57 over 10 meters. That will allow me to adjust my motor yield for further calculation, for projection to bit, and for planning my next slides. I use the same formula to estimate my current motor yield, and at this survey point my motor yield appears to be 1.5. But the thing is that I don't have any slide unseen beyond my survey point. That means that I can use 0 dogleg severity for projection to bit, or basically I can just use tangent option. So that's exactly what I'm going to do. I go here and I change it to tangent. Now I check my clearance, it's safe to resume. I check my distance from plan. Again, I'm a little bit ahead, but my inclination is absolutely okay. So what problem I have here is I still have this negative difference with azimuth, but that's manageable. That's exactly what I'm going to fix right now. So let's drill another stand. Another stand was drilled. Again, we had 4 meters of rotary. Then we performed 10 meters of slide, and then we rotated the remainder of the stand. We took a survey, and that was a survey, and now we know that between this survey point and this survey point we have 9 meters of slide, and we have 1 meter of slide unseen, and that's exactly what we're going to use in order to project to the bottom of the hole. When I pause this survey in Architect, I see that the dogleg severity that was achieved was 0.67, and again I just use the same proportion and I calculate my motor yield being 2.1. So for projection to beat dogleg severity, I'll use 0.1 as far as I have only 1 meter over 15 meters in order to project to the bottom of the hole. So in the Architect, for projection to beat, I will put inclination and azimuth 4.6 and 33. It will give me roughly 0.12 dogleg severity. When I updated my projection to beat, I check clearance tab, I check distance from plan, and as you can see my azimuth is getting better and better. I'm still a little bit ahead, but my inclination difference is fine. So let's drill another stand. Next stand was drilled, and finally we have this high side two-phase. As far as our inclination at the last survey, it was more than 4 degrees. That means that our MWD switched to high side two-phase already. So now we performed 7 meters of slide in 5 degrees of high side two-phase, and we rotated the remainder of the stand. When we took a survey, it shows that we are very close to our target azimuth, and our inclination is almost 6 degrees. When I pause the survey in Architect, I see that my achieved dogleg severity was 0.44. And again, motor yield can be calculated and adjusted accordingly. I use the same formula. My motor yield a little bit less than on the previous stand, it was 1.5. For projection to beat, I will use just tangent option because I don't see any slide unseen. So I basically don't have any slide beyond this point. So you can still use trend option, you can still use inclination and azimuth option, but it depends on how you are certain about the formation tendency beyond this point. So in my Architect, I will just use tangent option for projection to beat. And again, clearance looks fine, my available space increasing, distance from plan at my last survey and at my beat look ahead. I still have this negative azimuth difference, so I'm getting a little bit to the left of plan, but that's fine. Now we drilled another stand. So again, 4 meters of rotary, 10 meters slide in 35 high side two-phase, because we need to turn our azimuth a little bit, and we rotated the remainder of the stand. So this is our survey, and when I pause this survey in Architect, my achieved dogleg severity was 0.62. So again, I do the same calculation. I estimate my motor yield to be 1.9 over 10 meters. Now I have this unseen slide beyond the survey point, so I estimate the dogleg severity from this unseen slide to be 0.1, and now as far as I'm working with high side two-phase, I can start using dogleg severity two-phase option. So that will be my dogleg severity calculated from using this formula, and this will be my high side two-phase. So now I have adjusted my projection to beat using this dogleg severity two-phase option. Again, I check my clearance. It's getting better. Distance from plan. So now finally I have this positive difference for my azimuth. That means that I'm going to get closer to plan. Now let's drill another stand. On the next stand I have to focus on my inclination, on building inclination more, because now I have this negative difference in inclination. Azimuth wise I'm okay, so I'm going to get closer to plan, but inclination wise I have to maintain positive difference. So I'm going to focus on the two phase, which is 0 or close to this one. So now another stand was drilled and we have only 2 meters of rotary. Then we performed 12 meters of slide in 0 high side 2 phase, and we rotated the remainder of the stand. We took a survey and we posted in the architect. The outcome was 0.84, and again I use this number to calculate my actual motor yield in order to project to the bit and to calculate my next slide distance. So I use the same formula. My motor yield in this case is 2.1. I still have this 1 meter of slide unseen, so I use dogleg severity 2-phase option for projection to bit, and my projection to bit dogleg severity will be 0.1, calculated using this formula, and high side 2-phase. Basically it's 0 2-phase. And I just adjusted my projection to bit, checked my clearance again, checked my distance from plan. Okay, I maintain good positive difference azimuth wise. That means I'm getting closer to plan gradually, and inclination wise I am just on plan, but this negative difference will bring me behind the plan, so I have to focus on my inclination on my next stand. So now we performed another stand. We had 2 meters of rotary, then we performed 12 meters of slide, and we rotated the remainder of the stand. So we took a survey, we put this survey in the architect. Dogleg severity was 0.78, and we have calculated the motor yield. It was 1.8, and we calculated the projection to bit dogleg severity. It was 0.1, and again we are using the same option to project to the bottom of the hole here. So 0.1 for dogleg severity and 0 for 2-phase. 0.1, 0. So now clearance, again, good values here, save to resume, check distance from plan. Yes, I'm a little bit ahead, but again this negative inclination difference brings me just on the line, and I'm getting closer to the plan azimuth wise because I have this positive difference here. That's it. Good luck.